at point 1 over there. So, right, let's take this one, and I'll just see if I've got a black pen here. Right, there's a black pen. And we take this one along, and we draw it over there, and we come across that point over there. And that point on my chart is 0,012. So we put omega 1 is equal to 0,012. You get a mark for that in an exam. And then your moisture content at 0.2. Now, it's highly important that you work very accurate with this thing. So in other words, if you had to go and quickly draw in this thing, and your ruler is running at an angle like that, well, you're going to get an incorrect value over here, and your sum is going to be correct. Your latent heat, your effective room latent heat is going to be incorrect, which means that everything thereafter is going to be incorrect. And remember, as I said to you, that this part of this particular subject is of vital importance, because if you get this wrong, you're going to land up with everything wrong. Coil is going to be wrong, condenser is going to be wrong, evaporator is going to be wrong, your complete sizing of your system is going to be completely wrong. So yeah, you're doing everything sort of longhand, and you're using a chart. In the real life, you're going to get a computer program that you're going to bang in, and you're going to get all the values out of the computer program. That's the beauty of it. But the danger of working with a computer program that you don't know how they derive it is that you could land up getting completely skewed results out of the thing, and you wouldn't know that you've actually made a mistake. Okay, so in other words, we draw this one along over here for state point 2. And there we go, state point 2. We see it is 0,009. I'm going to zoom in. Hope it's going to clear up. Might have over-zoomed it a little bit. Sorry, guys. There we go. Right, there we go, 0,09. And you'll see it is on the first gradation after that. So that is 0,0092. Okay. A lot of people, when it comes down to like the 0,01, is that what they do is, if it is on the second gradation, or the first gradation, or the second gradation over there, you find that they will say it is 0,012 on the first one, or if it's on the second one, 0,014. Please be careful. It is not 0,012 over there. It is 0,0102. If it's on the second gradation, 0,0104, and subsequent to the 6 and the 8. Okay, because 0,012 is over there. So if you read that thing incorrect, and that one is particularly dangerous, that's 0,01. So in this particular case over here, we've got 0,0092. So if you write that down, state point 2, the moisture content state point 2 is 0,0092. Right. Here you've got your second bit of information. Put that onto the exam, onto the psychrometric chart in the exam. You will get yourself a mark for either of those. Okay. Right then, we say over here it is equal to 0,012 minus 0,0092 times the latent heat of vaporization, 2450, times 0,2. That's going to give us a value of 0,0092 0.779 kilowatt. So now our effective room latent heat is going to be equal to the room latent heat, 6.2 kilowatts, plus 0.779. That gives us a value of 6.979 kilowatt. I normally work to 3 decimal places at the end, and it's normally safe to try and keep down to 3. Okay, so that's now point number 2 of the recipe. Point number 3 of the recipe is determine the effective room total heat. And the effective room total heat is equal to the effective room sensible heat plus the effective room latent heat, which is equal to 21.035 plus 6.979, and that gives us a value of 28.0014 kilowatt. Right. Now the next thing you're going to determine is the effective room sensible heat factor. So point number 4 in the recipe, determine the effective room sensible heat factor. And that over there, the sensible heat factor, it's important because when we determine this thing, we're going to be able to further our progress on the psychrometric chart. Effective room sensible heat factor, and the ERSHF is equal to the effective room sensible heat divided by the effective room total heat. That gives us effective room sensible heat excuse me, was 21.035 kilowatt. Divide that by the effective room total heat of 28.014 kilowatt, gives us 0.75. Okay, there's no units for it because it's just it's a value. Okay, now I need to chat about your comfort zone. Now, a comfort zone in the course that we're dealing with now is always going to be at 24 degrees Celsius and 50% relative humidity. So there's our 50% relative humidity, there's our 24 degrees Celsius. So that over there, that point where it joins, I always put a little circle around it, like that. The square around the number indicates the state point, the circle around it indicates the comfort zone. I also call it the pivot point, okay? And the reason why I call it the pivot point is because we're going to use that point over there combined with that effective room sensible heat factor on this side over here to determine our apparatus dew point. Okay. So now we have a look, going back to our question. It said that the internal conditions that we were working with over here, the internal conditions, we said it was 22 degrees Celsius and 50% relative humidity. So now we're going to now indicate that value on the chart. And the way we're going to do it is we're going to say, right, 0.75 is what we've just worked out now. Has been our point. Time for a little bit of zooming in. I wish I could remember the direction this thing goes, but anyway, right, there we go. You're going to now take, there's 0.75 on the sensible heat factor scale over there, 0.75 is there. And we said that 24 degrees and 50% relative humidity was what we were looking for. Now, when you get an example that comes out, that they say that your internal conditions are exactly on 24 degrees and 50%, you're actually in the pound seats with regards to this this type of thing. And I'm going to demonstrate that a little bit later on, just after this thing. But what you do now is that our state point, our second state point, was at 24 degrees and 50% relative humidity, which is exactly on that swivel point. So we're going to now just draw a line from 0.75 through that state point 2, that 24 degrees and 50% relative humidity. We're going to draw a line right the way through, and I always suggest that you make that line reasonably long. Now, in this particular case, we're going to read off the next thing, which is the apparatus dew point. The apparatus dew point is where that line cuts through the saturation line over there. And so now we're going to look at it. There it cuts approximately over there. And draw a line down. Again, trying to keep it as accurate as possible, so it must be parallel with one of these sensible heat lines that are coming down. And we read it off. And we say the apparatus dew point, and I always put it down. And remember, in the exam, you'll get a mark for putting apparatus dew point, and you're going to put the value next to it. That's 5, 6, 7. Let me just move this up so you can see what I'm talking about over there. We've cut over there 5, 6, 7, 8, and that's about 8.6 if I look at it from our point. So let's say that's about 8.6 degrees Celsius. You get a mark for that. Okay, and we go and we write it down over here. And I say we read off the apparatus